Okay, hello everyone, welcome to next video. So here we are going to discuss about power rule and quotient rule. Okay, so let's get into the formulas first. So let's understand power rule with an example. So suppose an example is y equals to x plus 1 square. So we are differentiating it with respect to x. So dy by dx equals to, we are differentiating it with the power rule. Okay, so at that scenario, x plus 1 whole square, this x plus 1 will be differentiated, x plus 1 whole square will be differentiated with respect to x plus 1 at first. Okay, so we will write dx plus 1, whatever the coefficient is present here under the power, we need to differentiate it with respect to that at first, and after that we need to again differentiate it, and at last we need to differentiate with respect to x. Now let's solve this. Now this whole term will behave as x, and we have already known the main formula that x to the power n will be nxn minus 1. So this will be 2x plus 1 to the power 2 minus 1, and the derivation of x will be 1 and that of 1 will be 0. Okay, so the derivation of 1 will be 0, the derivation of x will be 1. So this will be 2 to the power x plus 1. So this will be our final answer in the power rule. I think this is enough for understanding the concept of power rule. Let me give you another example as well. Suppose y equals to ax plus b to the power 5, a little bit complicated one in algebraic series. So let's differentiate it with respect to x. So when we try to differentiate it, we're going to get dy by dx, dy upon dx equals to dax plus b whole to the power 5 divided by dax plus b, which will act as base now, and again we are differentiating it out so that we can cut this dax plus b divided by dx. So at first, while applying the power rule, we are differentiating ax plus b to the power 5. So ax plus b will behave as x in our formula, and 5 will behave as n. So it will be 5 ax plus b to the power 5 minus 1. It is similar to differentiating y equals to x to the power n, and we are going to get formula nxn minus 1. Okay. Similarly, dot, while differentiating this out, first ax will be differentiated. So if we differentiate out ax, we are going to get a, and if we differentiate it out b, we are going to get 0. Okay, so the final answer that we are going to get, write with another pen, so this will be 5 ax to plus b to the power 4 dot a. This will be our final answer. Okay, this is the main concept behind the power rule. Now let's understand quotient rule. Let me add this further. So now we are understanding quotient rule and product rule. If a given expression is given in the form of product, in the form of multiples, at that scenario for product rule we have formula u dv by dx plus v du by dx. Similarly, for the quotient rule, if the algebraic expression is given in the form of quotient in the form of division, so in that scenario we have formula v du by dx minus u dv by dx divisible by v square. Okay, let's try to understand with the formula for product rule. For example, suppose we have y equals to x plus 1 into x plus 3. If we are trying to solve the product rule, we can simply multiply it and solve it further, but let's solve it with the product rule. So differentiating with respect to x, what we are going to get is dy upon dx equals to this. The first term will behave as u, second will behave as v. So this will be x plus 1, differentiating v at first, which is x plus 3 by dx. Similarly, plus now x plus 3, which is v, will behave as a constant term, and dx plus 1 upon dx, which will behave as u here. So x plus 1 is our constant term. Differentiating this out, we are going to get 1, and the differentiation of 3 will be 0. Similarly, here if we differentiate it out, we are going to get 1, and the differentiation of 1 will be 0. So x plus 1 plus x plus 3, which will be 2x plus 4, will be our final answer. Okay, let's understand quotient rule with an example now. Let's move this further up. Okay, for quotient rule, let's take an example. Y equals to x plus 1 divided by x plus 2. Okay, let's differentiate it with respect to x by applying quotient rule. So dy upon dx. So here x plus 1 will be u and x plus 2 will be v. So our formula is v du by dx minus u dv by dx upon v square. It's a little bit complicated to solve this kind of differential equations. So this is x plus 2 here. Differentiating this out, we are going to get 1. Similarly, minus x plus 1, differentiating above term, we are going to get 1, and divide by x plus 2 whole square. Let me drag this screen. Okay. After this, x plus 2 minus plus minus minus x minus 1 divisible by x plus 2 whole square. So x and x cancel out. 2 minus 1, we're going to get 1, and 1 upon x plus 2 whole square will be our final answer. So up to here, we have concluded the main concepts of differentiation, which is power rule and quotient rule.